Hello everyone and welcome. In this video, we will explore MLOps, concentrating on MLflow. MLOps unifies machine learning development and operations. Key focus areas include automation of training and deployment, CI/CD for machine learning pipelines, and governance with proper versioning and auditing. Here is a quick look at machine learning lifecycle. We begin with data sourcing, collecting raw data, and then move to data labeling, where the data is annotated so models can learn from it. From there, we apply data versioning that keeps track of which data sets are used in each experiment. And then the heart of MLOps is experiment tracking. This includes iterating through model architecture design, training, and evaluation. A cycle that repeats until we find best performing model. Once models are trained, they go through model versioning. So every change is recorded, and then model deployment that they are put into production. At this stage, scaling hardware may be necessary to handle real-world workloads. Finally, we reach prediction monitoring that ensures the deployed model continues to perform well over time. Microsoft defines a maturity model for MLOps. At level 0, there is no MLOps, everything is manual. Then level 1 introduces DevOps, but models are still deployed manually. Level 2 adds automated training pipelines, and level 3 enables automated deployment and monitoring. And level 4 is full MLOps with end-to-end automation and continuous feedback. Now let's talk about MLflow. MLflow is an open source platform designed to manage the entire machine learning lifecycle. It supports experiment tracking, model versioning, and deployment, and also it works with multiple frameworks like TensorFlow, PyTorch, and scikit-learn. MLflow has several components. In this website, you can see all the components, steps, and stages. As you can see here, in MLflow website, we have different documents, including documents for 3 phases: build, evaluate, and deploy. Under build, we have MLflow tracking, MLflow model, and MLflow datasets. In this video, we review the first 2, tracking and the MLflow model. For evaluate, we have function evaluation, dataset evaluation, and model evaluation. And also for deploy, we have MLflow model registry and MLflow serving. In this video, we will review MLflow model registry. In this video, we review 3 popular components. First, tracking, to log experiments, parameters, metrics, and artifacts. Then we will review models to store and serve models in a standard format. And finally, we will review model registry, which is a central store for managing versions and stages. Getting started is simple. Install MLflow with pip command and then run MLflow UI on your server or locally on port 5000. This gives you a dashboard to view experiments and results. Let's begin and see how it works in a development environment. Here in terminal, we first run pip install MLflow to install the package. Then we run this command MLflow UI --backend store URI SQLite MLflow DB --port 5000. And as you see, it brings MLflow up on your local computer on port 5000. We simply go to website, and this is MLflow that it came up on my machine. Now let's begin with MLflow tracking. MLflow tracking let us monitor and compare experiments. We can log parameters, metrics, and artifacts, and organize runs into experiments and visualize performance trends over time. In Python, we can log everything with just a few lines of code. Before going to the programming environment and showing how MLflow tracking works, I would like to review the basic functions that we need in our Python code. First one is import MLflow. The second one is setting the MLflow server URI. And then we can give a name to our experiment using MLflow.setExperiment. And then everything goes into MLflow start run block. We can set the tag with .set tag, set parameter or params with .log params or log param or log params, and also log metric and log the artifacts. Now let's go to the programming environment and see how these functions work. We start with import MLflow. Then we set the tracking URI, which is a 127.0.0.1.5000. Then we give a name to our experiment. For example, we call it experiment 100, California housing experiment 100. And then developer, we set a tag. I set a tag developer Reza, and then log the parameter like data path that I'm going to download, housing.csv. Depends on my machine learning model. We have several parameters here because I'm going to use linear regression later. So I set param test size 0.3 and scaling normalization false. Then I log the parameters. For now, I commented the machine learning part to just highlight the functions for MLflow. MLflow log metric. Here I logged only mean squared error, and finally I save the model in format pickle file. Okay, now I'm going to do the same, but this time I'm going to add the machine learning part. So this is the same code. I just added scikit-learn, Python and pickle, pandas and pickle, and then this is the code for Kaggle Hub. I didn't change anything. This is the previous code that I explained. I just add this part, training model, to create a model using linear regression and do the training. And then I save the model, and here I run it. Now let me call this experiment, for example, 100. California housing EXP 100, and run this experiment. Okay, I ran it, and now it's done. Let me go to our MLflow. Okay, here in our MLflow, as you see, we have an experiment, California housing EXP 100. When I click on this experiment, it has our first run that happened 17 seconds ago. When I click on the run, it gave an automatic name to our run and a run ID here. This is the run ID, and this is the tag that I added. And these are the metrics, mean squared error. And also, if I click on artifact here, I see my pickle file that contains the model. Now, if I go back to this code and repeat the same code, but this time I'm going to store more metrics. For example, I'm going to store or log a mean absolute error as well as R2 square using these two commands. So this is exact the same code as before, but I'm storing more components. And then for experiment, I call it 110. Now I run it again. I get this successful message and go back to my experiment. As you see, experiment 110 is showing here, and it ran 11 seconds ago, and this is the experiment. And this time when I go down to the metrics section, I see all three metrics. When I click on one of them, it shows the chart for all three metrics: mean absolute error, mean squared error, and R2 score. So these are the two experiments that I created using my Python code. You also can search your runs through Python code. For this search, you need MLflow client. First, you have to set your tracking URI, and then using these filters, you can define a search criteria like a experiment ID, other filter strings like a condition for your metrics, and also you can define the maximum results and how, in which order the result should be returned. Let's go to the programming environment to see how it works. This is the code. We set the URI, then in search run we wrote the experiment ID and other filters. Let me go to our experiment. This is the experiment that we have, and here if I click, I see the experiment ID is 3 for this one. Yeah, experiment ID is 3, and we have 2 runs in this experiment ID. If I click on this chart view, I can compare the metrics for each run. Now let me go back to our programming environment and make this 3, and for now I make the rest, I comment the rest and just run it. As you see, it found 2 runs, and yes, this experiment ID is 3. Let me run it again. The next component is MLflow models. MLflow models provide a way to save, load, and deploy models. You can log model from any framework and deploy them across different platforms. To work with MLflow models, you need 2 functions. First, MLflow.frameworkName.log model. This saves the model in MLflow, and for the framework, in the next slide I show you the different type of frameworks that MLflow supports, like scikit-learn, TensorFlow, PyTorch, etc. And then the second function you need to know is loading model. That you need first to set a model URI, as you see here. Then using MLflow.pyfunc.load model, you can load the model. As you can see here, MLflow supports different frameworks like TensorFlow, PyTorch, scikit-learn, and many more. Before going to the programming environment, I want to show you an example. For example, if you use scikit-learn, we can log the model using MLflow.sklearn.log_model and the model name like this one. Also in MLflow model path, we can see these items: ML model, conda YAML, and model pickle file, Python YAML file, and requirements.txt. Also, to load the model, we get the model ID, we form the model URI, and then using this function we load the model. Now let's go to the programming environment and see how they work. Okay, in our programming environment, we go to our code. This is the code that we ran last time. We imported scikit-learn. Also, we import a data set from Kaggle Hub. Then we went to MLflow. We set the experiment. This time I call that experiment 200. Then we go to a start run block, set the tag and parameters and test size 0.3. And then we ran our linear regression code and we stored 3 metrics. But this time to work with models, instead of storing model in an artifact and store it through this function, I commented storing the model in artifact and logging another artifact. Instead, I use this function MLflow scikit-learn.log model and then the model that we used. Let me run this code and see the result. Okay, it ran. Now we can go to our MLflow, and as you see, we have experiment 200 here. When we go to the experiment, this time we see this model. Okay, and then when I click on run, we have run ID, we have our metric. Let me I go back to my experiment and this time click on model as well. This is the model that this time we got, and this is our model ID. And these are the artifacts that we discussed in this model. We have machine learning model, conda file, model pickle, Python environment, and requirement.txt. Now, here we have experiment with one model inside. Let me go back to our programming environment, and this time in this experiment 200 we do a change. Still this is the same experiment, but this time we change our parameters. For example, we make test size 0.4 and here test size 0.4. okay, and then run the experiment and register the model. Same thing. Let me run it. Okay, I ran the machine learning model, and now I see the same experiment, but when I click inside the experiment, I see my second model which registered 13 seconds ago. When I click on this model, I see the run ID, all the parameters, but this time see test size is changed to 0.4. So again on this model, test size is 0.4. This is the new one. Same thing, model and artifacts. Okay, let's go back to our programming environment. Now I'm going to load a model. I need the model ID. Okay, so I simply go to my MLflow interface, go to a model and get a copy of my model ID. I come here and load the model ID, the model that I had registered. Now I can load my model. As you see, I loaded the model and it showed me the MSE 167. Let me go to this one. See, this is the same model, mean square 167. You saw this one. This is the same model that I loaded using this model ID D6. D6 is here. Okay, so here you learn how to store a model, whether it's a scikit-learn or TensorFlow, and then load the same model. The next component that I'm going to review is MLflow model registry. The model registry is centralized model management, and using these components you can version models and also manage transition between stages like staging, production, or archive. Without a model registry, deploying a new machine learning model needs so many back and forth emails between DevOps engineers and machine learning engineers and researchers. And also it's hard to track the changes between different versions or manage hyperparameters and dependency, or even roll back to the previous model if some incidents happen in our production line. But model registry not only help us to track the log parameters and manage the best model for our product, but also it let us to assign a stage to our model, like a staging, production, or archived. To set a model in our model registry, we have to set model ID first, then model name and model URI. Then using register underline model function, we can simply register our model in our model registry. To register a model, I need to set the URI, which is this one. Then I need a model ID and model name. For model ID, I go to my MLflow and look at one of those models that I had in my experience. For example, in experience 200, I had this model ID 6A. I copy this code. It has a name, but this name is for this experiment. So I go back here, and first I set the model ID. We know which one is we are referring. I'm going to register it in a MLflow model registry. So I register this model as a cat classifier. Okay, and then I run it. Then I go to my models. As you see, cat classifier version 1 is here. Okay, now I go back here and register another model. For example, here let me go and look at the second model that I had here. Yes, this is cat classifier. I go here, and this model assume that the model ID is this one, and I put this model ID here, and this one is cat dog classifier. I run it and then go here. Now we have cat dog classifier version 1. Now if I look at my experiment, I see that my experiment also is referred to cat classifier and cat dog classifier. You also can search your model and get the latest version for your model using get latest version function. Here in our programming environment, first we set the model name. We need a model name here, so I go to our model registry, and I choose this name, cat.classifier, then client, and we run it. Now we can see the latest version is this one, and its stage is none. It means that this is a new model without any staging. You can also set the stage for your model using transition model version stage. We go to stage transition, we set the model version and the new stage, we call it a staging, and model name. Let's go and get a model name from here, come back, and now I run it. I ran call the function. Let's go and have a look at version 1, and as you see, it changed to staging. Version 1 staging. Now let me move forward from staging to production. Again, version 1 production, cat.classifier, I run it. I go back to the MLflow UI and click on version 1, and as you see, it changed to production. You also can update metadata for a registered model. So I go to update metadata for a model. I set the model version and model name here, and I will put a new description for this model. The model version was transitioned to production on this date. I run it. Now I go to my model registry and click on model. Then I go to version 1. Now version 1, this model, and this is the description. The model version 1 was transitioned to production on this date. The next function that I'm going to review is loading a model based on its stage and model name. In my programming environment, I load the model using its name and a stage. Okay, the model is loaded. Then I wrote a simple program to load the data and print MSE. And this is the execution of the loaded model from MLflow. Okay, thank you so much for your attention. In this video, I review tracking models and model registry components in MLflow. Also, I review the MLflow functions in Python to set experiments, search runs, log models, load models, register models, search model, and set the model stage, update the model metadata, and finally load and execute a model. Based on the feedback I get, I will release the next video on projects and deployment, model deployment using Amazon tools. Thank you.